Hello, students. Welcome to class. Today, we're looking into the fascinating world of atomic theory, starting with John Dalton's groundbreaking ideas and how they've evolved over time. Dalton's work was a monumental leap in our understanding of the natural world. So, let's get started. This is going to be an exciting exploration of the very building blocks of matter. First of all, what is an atom? This fundamental question has intrigued scientists for centuries. Well, an atom is the smallest particle of an element which can take part in chemical reaction. Or an atom is smallest unit of matter that retains the properties of an element. It's like the basic ingredient in the recipe of the universe. Now, back in the early 1800s, John Dalton, an English chemist, proposed a theory that laid the foundation for modern chemistry. His ideas were revolutionary at the time and have had a lasting impact on science. Dalton's atomic theory has 5 main points. These points were groundbreaking and provided a new way to look at matter. Number 1, all matter is made of tiny, indivisible particles called atoms. This was a radical idea that changed the way scientists thought about matter. This was a huge leap at the time, but today we know atoms are not indivisible. They're made up of protons, neutrons, and electrons. This discovery has opened up new fields of study in particle physics and quantum mechanics. Number 2, all atoms of the same element are exactly alike in all aspects. For example, in mass and properties, and are different from atoms of other elements. Dalton believed that atoms of the same element were exactly alike. Fast forward to modern science, and we find that this isn't entirely true. Advances in technology have shown us that there are variations even within the same element. Isotopes show that atoms of the same element can have different masses as a result of the different number of neutrons in their atomic nucleus. An example of isotope is hydrogen. Hydrogen has 3 isotopes: proton or protium, which has only 1 proton and no neutron. It has atomic mass of 1. Deuterium, which has 1 proton and 1 neutron and atomic mass of 2. The third one is tritium, which has 1 proton and 2 neutrons with atomic mass of 3. Carbon also has 2 isotopes, carbon-12 and carbon-14 isotopes. This discovery has been crucial in fields like nuclear medicine and radiometric dating. Number 3, compounds are formed by a combination of 2 or more different kinds of atoms. This idea helped explain the diversity of substances we see around us. This holds up pretty well. The formation of compounds is a fundamental concept in chemistry. When atoms combine, they do so in simple ratio. They create compounds with unique properties. These properties are different from the individual atoms that make up the compound. Number 4, all chemical changes result from the combination or the separation of atoms. A chemical reaction is a rearrangement of atoms. This was a key insight that helped scientists understand how substances interact. Dalton was spot on here. His idea that atoms rearrange during chemical reactions is still a core principle in chemistry. Chemical reactions do involve the breaking and forming of bonds between atoms. This process is what drives the vast array of chemical changes we observe. And number 5, atoms cannot be created or destroyed in a chemical reaction. This principle aligns with the law of conservation of mass, which states that mass or matter is neither created nor destroyed in a chemical reaction. This aligns with the law of conservation of mass. It's a fundamental concept that underpins much of our understanding of chemistry. However, in nuclear reactions, atoms can be transformed into different elements. This is a fascinating exception to Dalton's rule, and has led to the development of nuclear energy and medical imaging techniques. So there you have it, Dalton's atomic theory and its modern twists. His ideas were the stepping stones for future scientific breakthroughs. His ideas were revolutionary and set the stage for future discoveries. The evolution of atomic theory is a testament to the power of scientific inquiry and the ever-evolving nature of our understanding. Understanding these concepts is crucial, as they form the backbone of chemistry. Thanks for tuning in. Your curiosity and willingness to learn are what drive scientific progress. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more educational content. Your support helps us bring more exciting science content to you. Until next time, keep exploring the wonders of science. There's always more to discover and understand in this incredible universe.